table of contents. Page 184, exponential decay. On page 184, tape in the first page whole. Second page whole. Third page gets just that problem. Fourth page, which is page 187, gets that problem. All right, you guys ready?
Yeah.
Exponential decay occurs when a quantity decreases at the same factor over an equal interval of time. So it's being multiplied by the same factor, but it's lower. It's getting lower. Linear decay function occurs when a quantity decreases at a constant rate over equal intervals of time. Linear decay. So that is when it's being subtracted by the same amount every time, not by the same factor. Factor would be you're basically dividing it. Makes it smaller as division. All right, we cool with that? We see the difference? Linear decay function, you're subtracting the same amount every time. Exponential decay function, you're actually dividing the same amount every time, approximately. Exponential decay function, y equals a parentheses 1 minus r to the exponent of t. Y is your final amount. That variable obviously changes. I was using y. Your book used a sometimes. My thing over there says a for growth. Something later had a p. So just keep in mind the variable that's isolated to the left is your final amount of whatever it is. A is the initial amount you start with, same thing. R is your rate of decay, make sure it's in decimal form. 1 minus R is your decay factor. T is time. Okay, and that 1 minus R, if you're given a chart and you figure out what your decay factor is, then you don't need to do the 1 minus R. We had that one problem at linear growth where Jay was able to look at it and say, hey, I know that it's a 10% increase every time that's 0.1. And then I looked at it and I did the division and I was like, hey, it's 0.1 every time. And we got the same answer. So just you know. T equals time. How do the formulas for exponential decay and exponential growth differ? Mackenzie.
Exponential decay is going down, isn't it?
How do the formulas change?
Decreases.
You're looking at two formulas. Okay, so this is my exponential decay function. My exponential growth function, tell me what it is.
One of them had
No,
the
tell me what it is.
exponential growth.
Tell me the formula. I will hear only letters and numbers.
Y equals a parentheses 1 minus r close parentheses.
Nope, 1 minus r is a decay function. I'm asking you for the formula for the growth function.
1 plus r.
There we go. So now the question is, how are those two different?
One has, well, exponential decay has minus r, and the other one, exponential growth, has plus r.
Right, if I asked what's different with the functions, then you can say one's going up and increasing, the other one's decreasing. But because I asked specifically about the formula, it's one's decay factor is 1 minus r, the other one's 1 plus r. Everybody cool with that? So far you've got 3 formulas you have to memorize, in addition to everything else. But these are formulas. Okay, everyone's cool with that? Did you write that down? All right. What type of function is being represented? Ben, what type of function?
This one's exponential decay.
This is not exponential decay.
Growth.
It's exponential growth. Okay, so everyone's written that down? What is this one, JT?
Isn't that an absolute value function?
It is absolute value function. Good job. What is this one, James?
Is that exponential decay?
That is exponential decay. As your x gets bigger, your y gets lower. Jack, what's this one?
Is it linear?
Be more specific, please. It is linear, but we know what it's called because we actually just defined it today.
Linear decay function?
Linear decay. Very good. And Mackenzie, what's this one?
Linear growth function.
Linear growth. Do you guys get them all? linear decay, linear growth. Good job. All right. So you guys complained last time because I gave you like hints on how you're supposed to answer it, but when they said just describe it, like, well, yeah, I didn't say it, I had to say it. You're right. So this time we're going to say it right. So describe the pattern for this one. Look at how it goes from one to the next. What is the pattern, Ben?
You subtract by 3.
Okay. Subtract 3. So what kind of function is it? Ben?
What kind of function is it?
Mm-hmm.
Linear decay.
Very good. So you have to say them both when you're describing it. All right, the next one is pretty tricky. Jack?
Subtracts a bit of it, or it
Okay, so from here to here, what am I doing if I am subtracting?
taking 20% of it.
Well, that's maybe, I don't know. What did I subtract? 24 to 30 is plus 6, so I'm minus 6. Is this minus 6?
No.
No, so I definitely know it's not a linear one. So I have to use my calculator. Is it 20% each time? I have no idea.
No.
No.
Okay, so now I have to look at, I know I'm not subtracting the same amount each time, so now I have to see what am I dividing each time. So I'm going to do,
30 divided by 24.
next I'm going to do 24 divided by 30. So 30 times 0.8. Okay, so then now I want to know what I'm multiplying this by because it's a factor, it's not a quotient. So you take your second number and you divide it by the first number and it tells you what you're multiplying by, right? Okay, so what is this times to get this one?
0.8.
Okay, let's try this one. From here to here, I have to use my calculator and do 7.9 divided by 9.8. And it's not exactly 0.8, but it's okay because it's pretty close, right? So it doesn't have to be exact, and I'll show you how you know that in a second. So what is my pattern of decay, Jack?
0.8.
Okay, so I multiply by a factor of 0.8 or 0.8 every time. So what is my kind of function?
Exponential decay.
It's exponential decay. When you multiply by a proper fraction, it's getting smaller. So you know it's decay. Yes?
If you do 9.8 times 0.8, you technically rounded wrong because the answer.
Where am I looking?
On your graph. Not graph, your numbers.
7.9 divided by 9.8?
No. 9.8 times 0.8, it gives you 7.84, and that doesn't round up.
I copied off the thing. All right.
No candy.
See this right here? This 0.0? Do you remember from significant digits what that means?
It's showing that it's supposed to be rounded to the 10th place.
You're rounding to that tens place. So if I just had a 30, I'd be rounding to my ones place. Okay, so when you have this kind of number, you know that it's not going to be exact here. Okay, so because it's rounded, maybe that's why it looks like it's off. Okay, I don't know. I didn't make up these numbers. All right, you guys do the next one. Write it down in your book. Let's see if you're right. Keep in mind they're rounding, so your factors are going to be different. You have to end up kind of figuring out what your average is. Unless it's linear. It's not linear. All right, raise your hand when you think you have it. Remember, your growth factor, decay factor, is an estimate. Okay, so you know it's not linear, right? You figured out you're not adding the same thing every time. So you know it's exponential growth. So divide those two and see what that is being multiplied by.
By 1.01.
Okay, I'm just rounding to my hundredths. Now let's look at these two. This divided by this will tell you what this is being multiplied by.
1.03.
Okay, let's go to these two. Divide this by this.
.08.
Okay, so you can round. You probably, let's see here. What do you think?
Add them up and divide them by 3.
You don't have to be that exact. Let's try these two. Divide those two. Bless you.
.25.
Okay. So these are a lot higher than those. So I'd go in the middle of the two. So your growth factor is going to be about what? Can you just guess? What's in the middle between 1.2 and 1.0?
1.1.
Good enough. Okay.
Okay.
So when there's a lot of rounding going on, you just have to average. Do like, I wouldn't even look at this one because you can't divide by 0. So you know right there that it's going to be all funky. So I'd see, what's this one multiplied by? 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 And average those 4. And I averaged just by eyeballing it. Because I had like 1.8947, 1.1718, 1.0833, 1.03. So I called mine 1.1. Okay, did you guys do that? A couple different spaces?
Yeah, I was getting that.
And it's 1 point something, right?
Yeah.
So when I'm reading mine tomorrow, when I'm reading the answers, if you get to where you're a couple hundredths off, just say, hey, I think that one's an estimated one. And as long as you're close, you're good. Okay, so this would be, you would say it's a growth factor. I should say this is a decay factor. This one's a growth factor because it gets bigger. Of approximately whatever you guys said. I did not, you know, if I had done every single one of them and then added them all together and then divided by how many, I'd be a little bit more accurate, but it doesn't really matter. And then what kind of function is it? Exponential what?
Growth.
Alright, you guys cool? Did you all get this? Because I didn't walk around.
Not at first.
I didn't. Yeah,
But-
not at first.
I divided
because
the wrong way
I started.
first.
I started doing it, and then I was getting some of the numbers you mentioned, but I hadn't quite finished it yet. I was on.
Okay, so you were probably doing every single one.
Yeah.
Whereas I just estimated.
I was gonna do them all and then average them.
I missed this one out because you can't divide by 0.
Yeah.
And then I started doing a couple, and then I skipped a few, and then I skipped a few. So it's not an exact science, but if you only do the first 2, in this case, you're going to estimate a little too high. Okay? But because there's a whole lot of rounding going on, it's not going to be exact. So when you see these decimals like this, if it's not a linear, you're probably going to be having that average. Okay, you're cool with that? I never gave an example like that in the past, and they're all freaking out because it's not exact.
That's your average.
Okay, you're good? JTS, you still writing? Jack, you still
I'm almost
writing?
done. I'm just writing the function.
Okay. Okay, now, you know how to do these. because we already did it when we did exponential growth. So do this one first. Exponential growth, exponential function, or exponential decay?
Oh.
Or neither. Alright, you guys got all three done? I heard some pens being thrown down. Done. Got the mic. Kenzie, you good?
Oh, I forgot.
Oh, I did all three of them. So, what's this one?
Exponential decay.
Good. What's your growth decay factor? What's your decay factor?
Isn't it? Divide by 3.
Divide by
Well,
It's
times.
1/3.
Yeah, 1/3.
Because it's a factor, it has to be multiplication.
Yeah.
Okay, what's this one?
Exponential decay.
decay.
Very good. What's its decay factor?
1/4.
1/4.
1/4. Good. What's this one?
Neither.
Neither.
It's linear.
Neither.
It's linear technically.
Okay. Good job. It's linear technically.
Why did I put linear? I thought that was an option.
All right. By what percent does it decrease each year? What are they asking you for? Are they asking you for this?
No.
No,
No. What are they asking you for?
the percent decrease.
Okay.
So, okay, it's like a,
There is a phrase for it. What are they asking you for?
it is the decay factor.
Decay factor.
So smart.
Okay. You have to use the decay factor to find. So they're asking you for a certain variable. What variable is that?
R.
What? It's
T.
R.
Wait, oh,
So
yeah.
you're using the decay factor to find R. So what is the decay factor in this equation?
0.94.
Okay. So we have to set that equal to
1 minus R. right?
1 minus R. Very good. What is R?
0.06.
Yeah.
And that is it as a decimal. They're asking it as a percent. So the rate of decay is?
6%.
Good job. All right, you guys all follow that?
Yeah, that was pretty simple.
Yes. All right. Formula, plug and chug, baby. Write your chart. Write your formula. Y equals. Then write what each of your letters stand for, and then plug in. Do not just go straight to the plugging.
Let's see, letters. I know what they're supposed to mean. I don't know what it's like.
Oh, that's a nice one. Okay, so far you have that, yeah?
Yeah.
Hopefully you have a lot more than that.
Yeah. Cool.
What's your Y?
Y is Y.
I had it as 21,500.
No.
That's the initial amount. That's
That's your
it.
initial amount. Okay. R is what?
0.12.
Okay, 12%, written as the decimal is 0.12. Your T is
T.
T. Okay. So we had y equals 21,500 parentheses 1 minus 0, 1, 2 parentheses t.
Yep.
That simplifies to what?
0.88.
Y equals 21,500, 0.88. T, that's you telling me?
Yep.
Okay. When you graph it on your graphing calculator, your t is going to be what variable?
Time. Well,
On your graphing calculator,
X.
it's going to be your x. So, says to graph, use your graphing calculator.
and then if you just copy it off a graphing calculator.
Actually, no. Go ahead and put it in, see what it looks like.
It's gonna be. You have to zoom out a lot.
Yeah.
Oh, hey, I didn't pay attention. This is different than I have in my thing. What do I have? Thousands. It's okay, you're good. I'm good. I thought it was in thousands
Oh, I
of
can
dollars.
barely see mine after I zoomed out 2 full things.
Right, that's why I'm like, you're not really gonna copy it because you're not gonna start with 0 here.
Well, yeah.
Well, you are gonna start with 0 here. And then you can do this. And then we're gonna go to 21,500. At what interval do we wanna make these?
So like, go to 20,000 and 2,000s maybe.
What's 21,500 times 0.88? We're gonna go down, so my bad. We want this to be at our top, right?
It's 18,920.
So 18,920, 18,000. Let's go down by thousands. Okay, and you said when it is 1 year, it's, what'd you say?
It's 1 year, it'd be 21,000. Well, it'd be 18,920.
About here. Okay, then at 2 years, where is it? Are you guys looking at where he's looking on his graph? So, James, after 2 years, where does your graph say it is?
I didn't do it. I was doing it and then I deleted it because I did it wrong. And then I was looking at this.
Yeah, that's not mine too.
Okay, I'll wait. Or you can use just your calculator. I'm going to use my calculator and wait because I know that my t is going to be a 2. 0.88 raised to the second power times 21,500 equals
16,649.6.
16.6. Okay, so I see it's going to go like this. Alright?
0.88.
Now, I'm not going to use the graph to estimate my value after 6 years. You can. Let's do it exact. So if it's 6 years, which one of my variables is that?
T.
T equals 6. So 21,500 parentheses 0.88 raised to the 6th power is going to give me my value.
$9,984.
You did that quickly?
Yeah.
I don't know how to use this calculator.
I don't know. It's
Wait, did you look at
9984.687866.
Yeah.
Mackenzie, you good?
984.6.
I don't think I have everything yet.
You don't think you have what?
Everything yet.
What?
No, I mean, do you understand? Are you following? Because
Yeah.
we're going really fast today.
Sometimes I can feel like really funny, like ticklish, but it's so weird.
Alright, is that what you had?
Yeah.
Alright.
Oh.
Approximately.
I want to,
Wait.
I want to use my graphing pad. I want to
Wait. So I have the 21,500 times the 0.88 to
order of operations. You have to do this first.
Well, but putting it into my graphing calculator, I was just supposed
Did you do this?
not yet.
Find this number. I'm going to do my graphing calculator too, but I'll have to take that off the screen.
No, Windows settings.
Y equals A, parentheses 1 minus R,
I can
parentheses
never
T.
go back.
Y equals Y.
Escape.
A equals 21,500. Y equals 0.12. T equals T. Y equals 21,500.
So every time.
Yeah, I got mine zoomed out enough so I can see it.
Can you see the full graph?
Not full. It's impossible.
Exactly.
Alright,
Lines here.
Mackenzie, if I move this, is it gonna mess you up? Minus 3% because I didn't do any of my labels. My X label should be year since you bought the car. My Y label should be value of car. And my title can
And
be
try to write the price.
my car is worth nothing.
Try to write it in try to write the
Or why buy a new car?
Y-axis sideways.
Because the greatest loss is your first year.
Technically,
It's like
wouldn't
this,
you
DT.
think that if that's
This
the
DT like
price,
this.
once you sell it after
So right your X like
one,
this.
like, day before,
or what?
so
Well, yeah, what you like? What you why?
not
No,
Have you
your
not-
greatest loss is from your 0 year to first year because then it starts tapering.
I think the numbers are gonna be so much easier.
And it's constantly silver.
DT, that was easy. Look at that. Look at that. Okay,
Is
so
it
now,
on the numbers right now?
now you're saying these are values like that.
I'm at the titles.
That's what I'm doing.
Okay, I'm doing the. I still have to only do my graph. I'm literally looking for infinity that was.
Yeah.
Alright, wait. What were the new x-axis?
Alright, menu, zoom,
No,
out,
log is used. No, expertise.
up, up,
I
up,
already used
up,
my
up, up, yikes.
Mine wasn't
Okay.
like that.
How do you guys use, let's see here, I wanna see, is there an easy way to see where it hits 6?
No.
I think you zoom in on a specific
Well,
spot,
unless
maybe.
you.
Maybe just zoom in on a specific spot.
Oh,
Hit escape if you got stuck on that.
zoom. Alright, what about analyze graph?
Yeah, there's only one line.
So basically we have to do this by substituting in, not looking at our graph.
Yeah, pretty much.
Alright,
Oh!
Mackenzie, you good?
I think I have it.
Jack, you good?
Yes.
You have all that?
Yep.
We have this and we put our proper stuff on it?
Need an
Who
approximation.
needs a graphic calculator?
Yeah.
Yeah.
This is a scientific calculator.
Yeah.
Yeah.
What he said.